Welcome back, everybody. So you've now had a chance to play around with the simulation for a few minutes, and you have almost certainly observed that there are circumstances where light will bend when it moves from one medium to another. We are going to talk a little bit about that phenomenon, which is typically called refraction. And you can see a diagram of how refraction works here, along with the reflection that we talked about earlier. And what you will notice is that the light that comes in from the left will hit the boundary between one substance and another. Some of that light will reflect, and we already know how to handle that. And some of the light will refract. It will bend and continue traveling through the medium. One thing you'll notice is that I've drawn a dashed line, which is perpendicular, normal to the interface between the two substances. All of the angles that we are going to measure should always be measured from that normal line to the ray of light that is intersecting with the medium. Once that happens, you can use something called the law of refraction to calculate the angle of refraction. You can do that by multiplying something called the index of refraction by the sine of the relevant angle. The index of refraction is actually a measure of how fast the light is traveling in the medium. You simply take c, which is the speed of light in a vacuum, and divide it by the speed of the light in that region. That speed is always going to be less than c, which means your index of refraction is always going to be 1 or greater. And depending on what the index of refraction is, you might get different behavior with the light. You could have it bend towards the normal line, as is shown in the picture, or you could have it bend away from the normal line.